What's good?
There's a competition at the school for who can make the best predictions for the games. So currently, yeah, the school.
Okay.
Currently, I'm winning.
Who are you saying?
Huh?
Who are
I
you?
don't remember. Uh, because what I do is I look up some statistics for the team and then make that my prediction.
So what is your prediction?
Because I don't remember.
Remember that?
No, do you know you are winning?
Oh, because it's the website and you put in your prediction and it keeps a score of everybody and it puts a leaderboard.
Oh.
Yes.
And it happened in this school?
This school? Yeah, the IFC.
What's the price after?
I don't know, it's not clear. It's not clear. And I think as people start to lose and as I start to get more points, people aren't really talking so much about this. Yeah, funny that, isn't it? Alright. And I'm number 19 in Ireland.
What? You mean your number?
No, like they have everybody's score in Ireland.
Oh, what? There's this competition in Ireland.
Oh yeah, like you can see how you're doing in the school, and then you can see how you're doing in your country.
Do you check who will win or the points?
What do you mean?
You have done who will win.
No, the score.
Or just like the points.
Yeah, the points, the score, yeah. Is this not?
Did you get it right for Germany?
I tell you, I did get it right for Switzerland, Brazil.
Mm-hmm.
I said 1-1. Everybody thought I was crazy. Like, but Brazil will definitely win. I'm like, yeah. Are you not watching?
I was.
Who are you watching play?
Sweden, South Korea.
Oh yeah, you'd probably be watching South Korea play. Yeah, that makes sense. Yeah.
And I look that.
Well, at least South Korea is in the World Cup. More than what I can say about Ireland. All right. Oh yeah, easy peasy stuff.
Backward.
Huh? Yeah, graphs of log A and log N. Yeah. Got that? Yeah? Is South Korea the only country represented in this classroom? I don't think China's in China. No. Just South Korea.
Yeah.
So do we all have to support South Korea since maybe. Yeah. Okay, shown below is the data for a radioactive sample. The N we can see is decreasing. So you'll need to use graph paper for the exam. But if you were to plot this, well, I think you know what the shape is already, don't you?
Exponential decrease.
Yeah, so what shape is that? It's going down like that, isn't it? Yeah. So let's plot this really quick because we'll need to do this for your exam. Although, well, let's have a look.
Oh.
What?
Yeah.
What?
You and Ivan already said like, let's have a look.
Really?
Yeah.
Let's have a look.
Yeah, let's have a look. It's common for you and Ivan.
Maybe it's a maths expression.
What's that?
Maybe maths people say this. Do you know? Right. Let's have a look. So, time, seconds, and N moles. Okay, so we're going from 0 to how far now? 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this is 10 moles. Is it 10? Oh, sorry, it's 100. Sorry. 100. And then this is 100. 70.7. So that's, we'll do 1 decimal place or 2 decimal places. And then, oh, for God's sake.
Come down.
Okay. Okay. What the?
Yes.
Thank you. Alright, so we're going all the way down to, about, yeah. Right, I'm going to graph this, but before I graph it, I just want you to do a very quick sketch. Well, actually, no, you can see the graph first before you do the quick sketch, but I think everybody has a good idea of what shape this graph will look like. Just, yes, exactly that shape. Okay, so we'll connect it. We'll connect it like this. We won't put it like that. No that. It's n against t time. What's so funny? What? Are you okay? What? What did I miss?
What's that?
Well, yeah, what's your point? Good question, Bruce. Good question. Oh. Oh. What's so funny?
Are you crying?
Yeah, it's hilarious. We'll leave them. Okay, right, so this is what the graph looks like, as you probably thought, exponentially decreasing. So what I would like you to do is to copy the table and the graph. Now, you don't have to make the graph too neat, okay, but just get the general shape, please.
I can't really ask this graph before.
I've seen them ask this graph only once.
Only one.
For this one, yeah, because they prefer to ask graphs that have straight lines.
So they ask like the LN thing?
No, they're a bit sneaky about it because they won't say it directly. So if they want the LM, they won't say that. They'll say something like draw a suitable graph.
And this is not suitable?
It's not. But if they just said draw a graph, then it's this.
So how is this not suitable, isn't it?
It's not suitable in physics because in physics, when possible, you should try to graph a straight line. Yeah.
What's this graph for?
Say again?
When do we draw this graph?
You really shouldn't. The reason I have to do this graph is because once they asked the student to make this graph in the exam, but 99% of the time it's a different graph will be drawn, which we'll see in a minute. But the reason we don't usually graph this is because it's not very useful, because there's not much you can do with the graph. You know?
But what's its point?
So the question, it would just be something like graph the, in this case it'd be graph the number of atoms. But really the question should usually say make an appropriate graph of the number of atoms. So then we'll have to use logs. You know. But right now it's not very useful because all it's doing is telling us something we already know, which is that it's exponentially decreasing. Okay, can I continue? Yes? Yes? So, as you can see, it's exponentially decreasing, which is not a surprise. But the reason, you asked me why, wasn't it? It's difficult to get information from a curved graph. This is why we don't use them in physics so much. We can see what the n0 is from the graph. So if I look at this graph, what's the n0?
In euro.
Yeah.
In euro.
Yeah, so what number is it on this graph?
It's 100.
It's 100.
Yeah.
Yeah. But what's lambda?
It's hard to find it.
Yeah. Unless we do something to the graph.
Low-key.
So let's take the log. So in this table, what I did was I replaced the n with the log of n. So I'll just go back here, and I'll just do that. Come on, how do I... Okay. So just give me 1 second here. I just need to get the log. Oh, for goodness sake. No, that's wrong. One moment. Log. Okay. I want all the logs. All of you guys go there. Right. Back to 0. Back to 1. There we go. So what I've done is I've taken the log, and instead of plotting the n, I'll plot the log of n. So instead of plotting n, come on. The log of n. Wonderful. Alright, so this is what the graph will look like now. And you notice that's very different. You get a very different graph if you use log of n instead of n. What I would like, if you can copy this graph now. Now, let me just use, how many decimal places? 2 decimal places. So. Oh. That's not 2 decimal places, you...
What?
Does anybody know how do I make these 2 decimal places? Format. Ah, 2 decimal places. There we go. Okay. So if you can copy this now. Can you see it okay? Yeah. It is, yeah. You copy this? Did you? Really? Show me. Wow. Exactly the same. When's your presentation? You get your time?
No.
Hmm?
Maybe next week.
Next. Tell me when you get your time.
Nope.
I can just ask Connell.
Why?
Did you do any practice?
Not yet.
Not yet?
Maybe tomorrow.
Tomorrow. Oh. What time?
Afternoon.
Why? Why?
Hmm.
Do you want to join for Way's presentation?
Go away.
Not just Wade.
Maybe Rohan?
Yeah, maybe. Yeah. Oh no. No. He's doing chemistry, but
Not exactly chemistry.
what then?
Atom.
Oh, well then I'll join too, yes.
But not
Ah,
exactly.
no, it's okay. I'll join. I'll join tomorrow.
You know, but not exactly physics. And not exactly chemistry.
I'll judge for myself. Yeah. Okay, did you draw this now? Yeah. So you all notice that now we get a straight line. So please, in the exam, when they say graph in a suitable manner, or graph in an appropriate manner, or draw a suitable graph, or draw an appropriate graph, what they mean is you must take the log before you graph. Okay? Now, in fact, what they sometimes do in the exam is they give you a table like this, but then they leave space at the bottom, and this is where you have to add in the log. I've seen this at least once. Okay? So, let's continue.
Question.
Yeah.
If they do that, do we have to copy like the whole table to the paper, or can we just write like Ellen and?
No, it's okay. You can just copy your part. Yeah, not the whole table, yeah. Okay. Notice how my graph is linear. Okay. So, we have this formula. What happens if we put log on both sides? Now, we've seen proofs like this before.
RC.
Yeah, the RC one. And
I equal I0 e to the power of e to the power minus.
the capacitors, yeah. Was there somewhere else we saw a proof like this?
Yeah, another thing. What's the name?
Materials?
Which one?
And materials are drawing.
Yeah. Wasn't there something? Was there?
Interferes.
Anyways, it doesn't matter, because you would have seen stuff like this in maths class as well in semester 1. So, this is one of the proofs in the exam. It's the same as the RC proof, where what they want you to do is to use log to figure out what does the slope of the graph represent. You understand? Now, I can show you this, but actually maybe it's just a little bit of revision for your maths and physics. I want you to try and figure out what this graph here, what does its slope represent? So by using logs, see what you can make and tell me what you think the slope is. So put logs on both sides, okay? See what you can get. Now write it down, Wilkie.
I know.
Okay, good. Then continue sitting quietly.
Quietly. Silently.
Yeah, silently, yeah.
That means shut up.
No. You got it, yeah? And we'll just give 1 more minute. Did you? Okay, so Bruce, did you do this? Yeah. Yeah. Yeah, up here. Yeah. So, what did you get over there, guys? Bruce, what did you get for the slope?
I can look one. I'll look and call M0 5
Lambda t. Yeah. So, which part of that is the slope? You know what I mean by slope? The m, the slope on the graph, the slope. Do you understand me, or am I confusing you? I'm confusing you, yeah. Let me explain. So, you know this y equals mx plus c? I want to know the slope, the m. Yeah. What do you think it is? Say again? Oh, close, close. What is it? It's just the lambda. Because the t is like that, is the x part, yeah. Did you get this as well? I think it's actually, is it minus lambda? I don't remember. Minus lambda, yeah. Did everybody get that? Yeah, so you don't need me to do it then, but the result is you should have gotten this. So the x is the t, okay, we know this, and the y is the log n, we know this, but the m is minus lambda, and the c?
Minus plus log n.
The log n 0, yeah. Okay, good. So maybe the only thing you don't know is the verb here.
Linearizing.
Yeah.
Make it to linear.
Correct.
Like-
Yeah. Yes. I think you should write this verb down. I'm not sure if it's a real word. I'm pretty sure it's a real word. I'm pretty sure.
It makes sense.
It makes perfect sense. It makes perfect sense, yeah.
Linearizing.
So it means after you linearize, then you get
See, the word makes perfect sense, yes. After you linearize, yes,
you get the
you get this result, yeah. There's a couple of words which I don't think are in the dictionary, but they're used in maths and physics, but they make sense.
I thought you made it up, yeah.
No, not completely made up by me, but I'm pretty sure this one's in the dictionary. But there's another word I use which isn't in the dictionary, and it's the opposite of dimensionless. What would you say the opposite of dimensionless is? Dimensionless means no dimension, no units. Yeah, so what would be the opposite of dimensionless? That's what I say, but apparently this word is not in the dictionary.
What's that?
Say again? Dimensionful.
Dimensionful?
Oh.
Yeah, but it's not in the dictionary, if you can believe that. Right, next now. So you can do the same thing with A, not just N. So with the A, kind of similar results. Y equals log A, x equals t, m equals minus lambda, and c equals log A 0. So it's, what I think is very interesting is even if you plot log A or log n, in both cases, the minus lambda is the slope. So in fact, it doesn't matter if it's the activity or the number of atoms. If you use the log of it, you can get the lambda. Yeah? So you might want to write this one down as well, please. Now, can I continue? Yeah? So just before I do this question, there's something very useful I want to draw your attention to. I can't remember if I said it when we were doing the RC graphs, but I'll give it to you here, okay? So let's imagine we have two graphs, or sorry, let me go back a step, okay? So we have our data, and for example, here maybe we use moles, and maybe here instead of measuring the moles we just measure a number of atoms. So this one here, the numbers will be smaller because you're using moles. So like for example, here maybe when t is 0, n0 could be 1 mole, whereas here when t is 0, n0 will be 6 times 10 to the 23 atoms. Okay? Will that affect the graph? Let's have a look here. So in this graph here, this is time in seconds, and this one here is time in seconds, and this one here is log n, and that's in log moles. And this one here, actually hang on, I can actually rotate this to be easier. Oh yeah. What's this special effect? Yeah, it's great, isn't it? Log n in log moles, and this one here is log n in log number of atoms. just like PlayStation 4. Okay, continuing. So you might think that actually will affect the slope, because the slope uses the y and the x. So for example, if I have 2 points here, let's just call them x1, y1, x2, y2, and the same here, x1, y1, x2, y2. Are those points different? Yes, because in this graph, can you see that this y will be much smaller than this y? Because here we're using moles. So they're different numbers, right? Let's have a look at what the units are. Okay, so the units for lambda, that will be the same thing as the units for y2 minus y1 over x2 minus x1. Now you know from semester 1, week 1, lesson 1, if you have to add two things together, then the units must be the same. So this is the same as the units for whatever's on the y over the units for whatever's on the x. Yeah? But just to be a little bit clearer, the y2 and the y1, to be a little bit more precise, that's actually log n2 minus log n1 over t2 minus t1. But you can use your rule of logs here. What do you get for log n2 minus log n1?
Log n2 over n1.
Yeah. Over t2 minus t1. Now that's really important, because what are the units for this?
No unit.
Dimensionless. No units.
Yeah.
No units. Which means, in fact, the units don't matter, because you can do everything the same here, and you end up with the same thing. Log n2 over n1, but these are number of atoms and number of atoms. But it doesn't matter it's a different unit, because the units cancel. So what's amazing is, even though they're different units, you actually get the exact same slope. So it means that you don't have to worry about if it's moles, Avogadro, 10 to the 23. Because you're using the log, the units disappear. So the only units that matter is the units for time. So your lambda will be in the units that you have on the x-axis to the minus 1. So if I'm using seconds in both of these, what will be the units for the lambda? S to the minus 1. And the units for the n have no effect on the lambda. That's very useful to know, because sometimes students think, oh, the data is in moles, so I need to convert it before I can get the log. In fact, you don't. By getting the log, it doesn't matter about the units anymore. Okay? So the result here is for log n, units are not important. And this is another reason we actually use log, because it's nice when we want to calculate the slope to know that the units don't matter.
But actually you did it in the RC lesson.
Did I? You see, I wasn't 100% sure if I did.
Yeah, you did.
So you've seen it twice?
Yeah.
Wonderful. So just make some small note here about the units.
Unit is not important.
No.
You said unit is not.
I said for log n, the units are not important.
For this case.
For this case, yes. Usually units are very important.
I know that.
Yeah.
Only for calculation.
Calculate the slope. Yeah. Yes, for log n, units are not important for
Only this case.
lambda. Yeah.
Yeah. If I solve the question, I use two ways, but one way is wrong. Second way is right. Can I get full marks?
Oh, and you have two different answers.
Yes. Oh no. Yeah. No.
Which?
But got same answer, but this process is wrong. This is right. if I write everything, can I get full mark?
Yes,
Yes?
yes. If I'm correct in it.
Oh yeah.
Okay. The instructions from NCUK do not include instructions on what to do when students do this.
What do you mean?
If they give me instructions on how to correct,
Yeah, yeah.
they don't tell me what to do if someone does this. So in these cases when they don't tell me, I always choose what will benefit the student, unless I don't like the student. But usually, yeah. So. Right. Did we write that down? Yep. So let's have a look at an example.
Have a look. Common things for Irish.
Is it common?
I don't know.
Does your other teacher say it? Right. Let's have a look here.
Let's have a look.
Yep. Well, what would you prefer I say?
I don't know. I just say.
Let's do it.
Let's,
Yeah.
Let's look at it.
Activity in mole equals. Okay, and the time from 0 to 10, and this is 10, and this is that over okay. Now, that's not the graph I want, because it says graph this in an appropriate manner. So what should I do here? I should log it, yeah. Okay. Equals log of this. Copy this down. Paste it here. Paste the numbers back to 0. Equals 1 plus that. Copy it down. Right. Oh, and I need to fix this. So instead of log n, what should I have here?
Log A.
Log a. Log a against t. Oh, sorry, I shouldn't say moles there. That's t in seconds, and then here.
Log A. Okay, go ahead.
Ah.
Go back.
Okay. Log a in log BQ moles, isn't it? Right, there we go. Now obviously it will take you longer to do this in the exam, since you don't have a computer, so good luck with that. There we go. So I've just done the first part here, graph this. Yep.
Yeah.
Okay. So just roughly copy this graph in your notebook. Yeah. Yeah. Like, for example, I would like you to at least copy this number. Sorry, can you see? Like, copy these numbers at least and these numbers. But I don't need you to be super accurate with the line. Or if you want, just copy these two numbers and this one number, if you prefer.
We're gonna have extra class
Why?
yesterday. No?
I mean, what have we got left here? 5. We'll do another one today. So after today, there'll be 4 topics left.
4 topics.
Yeah, and that's it. We don't have any more assessment support.
Yeah.
So we're doing great. We're doing great.
After finish hoarding, we're gonna take what's it?
Revision.
Yeah, revision.
Yeah.
Oh, there's still class?
Yes.
You don't want?
She doesn't like her physics teacher, you see.
Oh, the
Yeah.
physics teacher does.
No, my feelings are the same for all my students.
Trust you 100%.
Yeah, well, I never said they were good feelings, though. Just that they're all the same for all my students. Okay. From your graph, estimate the lambda. Right, so we'll need to calculate the slope. So we can just use the formula from maths, y2 minus y1 over x2 minus x1. Now, can you help me read this here? So, I think what's good for these graphs is if we can use this as y1, x2, y2. So, if I just zoom in a bit here,
2.25 up 2.2, 2.2.
well, I suppose we know it's 2.3 if we look at the data. So that's 2.3. And this here is obviously 10. And that's 0.57. So can you just type in on your calculator 2.3 minus 0.57 over 10? What do you get?
Minus
0.173.
not minus.
Well, we can cancel the minus because lambda equals minus the slope and the slope is going down. Anyways, you know that this should be a positive, be careful. What do we get?
0.173.
And the, yeah, but we know that we cancel the minus. We know the lambda should be positive anyways. Unit?
Unitless. Oh, not
unitless.
Per second.
Per second. Yeah. Now, what's the half-life of this sample?
Right?
Should be, what's the formula we had? T a half
ln2 over minus
ln2 over lambda.
minus
Lambda.
lambda.
Which equals 4 seconds here. Lambda, that is 4, isn't it? 4 seconds.
How? How did you know?
I'm a genius.
She doesn't even remember.
No, not true. Not true. I'm a genius.
You remember
I'm
that?
a genius.
So genius.
Yes. So the answer has to be 4. Yeah. Okay. Oh, that's C. Oh, the graph was part A. So that's B. That's C. Okay. D. What is N0? No.
Use the
Yeah.
power.
No, you have to be careful. That's the A activity. So what we can use the formula A equals minus lambda n.
Yeah.
So that means N0 will be A over minus lambda. The A is
Bum, bum.
10 moles.
Yeah.
Moles. And the lambda, or the minus lambda, well, the A is minus 10, technically. Activity is
Yeah.
negative,
Yeah.
technically. So like technically these numbers are all negative, but like I said, because of the language, we know it's minus because we always talk about the decay, like deceleration, so it's minus. Over minus 0.173, what's that please?
57.8.
57.8 moles. Moles. Okay, and E. What is N when T is 11? So the next second, what would the N be? So it's N equals N0 E minus lambda T. That would be 57.8 E minus 0.173 times 11. So what's that going to be? About 1.5? Is it?
8.62.
8.62. Oh, sorry, it's N. 8.62 moles.
What is the unit mole? A is
Because A is in moles.
lambda is in second.
Well, okay, if we're being super technical here, the A is in moles per second, and the lambda is in per second, so we're just left with moles. Okay. This is wonderful if you get it as a section B question. You know, it's make a graph, answer some stuff on the graph. Very, very nice section B question.
What's the total mark?
For something like this, Usually this would be 4 marks, this would be, for the graph,
So nice.
this would maybe be another 4,
Another
this
4.
would be 2, 2, 2.
14.
Yeah?
This is good.
Yeah, so then, the question's usually 20 marks, so then if that's what we say, 14, then there might be 3 marks on where we have to balance an equation that we did last week, and then the other 3 marks could be something like, it'd be something like, for example, let me think, definition, or maybe something like, they actually maybe could ask you to prove that the slope is minus lambda, for example. They might ask you a definition, something like this. Yeah. So it's a good section B question to get this one.
Section G is good.
Yeah.
It's not hard. Section
No, hang on, calm down. Alright.
Yeah.
Okay, so just the one question for you to practice. Just be careful. I tried to make this a little trickier. This is in mega equals. So this is 10 to the 6 atoms destroyed per second. So this number here represents 5 times 10 to the 6 atoms destroyed per second.
Not more.
And not using moles, yeah. So I'm just trying to make it more interesting for me.
In the exam, can I change that m to 10 to the 3?
Yeah, but as we learned, this unit has no effect on part B.
Yeah. Just
But yes, you can.
Yeah.
Yes.
When we plot the graph, do we have to change it to like ln 5 times n5?
No, because my point I'm making is, if you just did ln 5, then the slope you calculate would be exactly the same.
Then what do we label on the y-axis?
Yes, you could say it's log n slash, and the units are log megabequals. Yeah. Let me just stop the video and I'll let you copy this down.